Okay, so when you're working with indices, there are a number of laws that you need to be familiar with. The most basic is multiplying, and whether you're working with numbers or letters, I'll start with letters. If you have expressions where the bases, this part is called the base, and this is called the power or the index. If the bases are the same, then you can combine and simplify those expressions. Now, the sort of long way of thinking about that is, well, x squared I know is x times x, and then I'm multiplying that by x cubed, which is x times x times x. So what I end up with is multiplying x by itself 5 times, which I can write as x to the power of 5. So if I'm multiplying, we can see we don't have to write that out like that. I can just add the powers. And that would be the same, as I said, if it was with numbers. So if I had 2 to the power of 4 times 2 squared, that is the same as 2 to the power of 4 plus 2 is 6. If you've got a mixture of bases, so let's say we have x to the 5 times y squared times x cubed times y, I can combine the x's because they have the same base to give x to the 5 plus 3 is 8. And an important thing to note is that if there isn't a power above the letter or the number, then in fact there is a number there, which is the number 1. We don't bother writing it in. It's not a 0, it's the power of 1. So the y term will be y to the power of 2 plus 1 is 3. So that's multiplying. When you divide, if you imagine we've got x to the 7 divided by x to the 3, well, divide in algebra we would write like that. And if we were to write that out longhand, as I did in the first example, you'd have x times itself 7 times on top. 1, 2, 3, 4, 5, 6, 7. And underneath, and what that means is that you can divide top and bottom by x, which to all intents and purposes cancels them out, and another x, and another x. No more x's on the bottom, which means then there isn't a 0 under there because, again, everything can be multiplied by 1. So that is saying there's a 1 left underneath, and on top, x to the power of 4. So the relationship here, you can see from these indices, you've got a 7 and a 3, and when you divide, you're left with what you get if you subtract them, which is x to the power of 4. Now where a negative indice comes in is if, let's say, rather than x to the power of 7 divided by x to the power of 3, we had it the other way around. So using the laws of indices, that means we're going to do 3 take away 7, which is x to the power of negative 4. Well, what on earth does that look like if we write it out longhand? Well, what that would look like is on top we'd have 1 times x times x times x. On the bottom we'd have x times x 7 times. 1, 2, 3, 4, 5, 6, 7. So we'd cancel 3 of those, leaving us on top 1 over, and on the bottom x to the power of 4. So what that means is the negative power is another way of writing the reciprocal 1 over 4. So a negative power means 1 over. Or if you had 1 over y to the minus 3, that would actually mean 1 over y to the 3, which would mean y cubed. So that negative is telling you it's 1 over, or basically turn it upside down and lose the negative. Then you could combine all three. So you could end up with something like x to the 4 times x to the minus 3. So you're adding, because we're multiplying, but we're actually adding to a 4 plus minus 3, which is 1. Or you could end up with x to the 2 times x to the minus 7, which means you're going to subtract those. So you'd end up with x to the minus 5. Sorry, you'd add those, but the 2 plus negative 7 giving you x to the negative 5. Or you could be doing p to the 4 divided by p to the negative 6. Or if you're dividing, you know you're subtracting, so that's going to be the same as p to the 4 minus negative 6, which is going to be p to the 4 plus 6, which is p to the power of 10. So all the negative tells you is that you're going to end up with 1 over. Hope that helps.